I talk to students a lot about taking ownership of your education and being intentional about your learning. In part, being intentional means recognizing that every moment is an opportunity for you to make a decision, deciding what to think and what to do, even deciding how to decide. And as a neurobiologist by training, I wondered, how can understanding the neurobiology of decision-making help us be more intentional decision makers? When we make a decision, we are actually influenced by two different systems in our brains. One of these systems operates mostly at a subconscious level, and the other system is what defines us as human, at least from my neurobiological perspective. Through the course of evolution, there has been an expansion of neocortex in primate brains, and compared to other primates, humans have relatively large brains for our body size, with a lot more neural cells, with more connections among neurons, and with a generally higher level of complexity and flexibility. As a result, we excel in higher cognitive processes, including the ability to think critically and creatively, to problem solve, and to understand the consequences of our actions, even when those consequences aren't immediate. These capabilities are due to a great extent to the workings of a portion of the brain known as the prefrontal system, which includes neocortex in our prefrontal lobes. You are going to be using your prefrontal system a lot to get you to graduation. Now, thanks to our prefrontal system, the human brain has all the capabilities we need to address any wicked problem. The same capabilities, in fact, that create the technology and social systems that get us into wicked problems in the first place. Wicked problems like global pandemics, devastating wars, and climate change. So with our complex, highly capable brains, why is it that reasonable people can disagree on the basic facts, the stuff that has the most evidence, like the reality of climate change, or the importance of public health measures during an outbreak? And how can a neurobiological perspective on this question help? To explore this, we're going to do a quick dive into the neurobiology of how we decide what to believe and how to behave. Obviously, our evolutionarily newer prefrontal system plays an important role in decision making. But, and this is critical, it isn't the only brain system involved. When we make a decision, the prefrontal system has to work with and sometimes argue with the evolutionarily primitive but powerful limbic system. The limbic system operates in the shadows. It is physically located deep in the brain, and it mostly operates below the level of our conscious awareness. This shadowy nature gives the limbic system some of its power. Because it acts subconsciously, the limbic system can influence your behavior without you ever being aware of it. The limbic system also had to be powerful enough in driving behavior to help our ancestors survive to live another day. So keep these two players in mind. The prefrontal system, which is critical to our ability to think beyond the present time and place, and the limbic system, which is something of the opposite, evolutionarily older and essential to the short-term survival of the individual, whether that's a human, a wolf, or a mouse. Every decision we make involves these two players, and their influence on our decision reflects what each system has learned. Surprisingly, the prefrontal system and the limbic system are actually learning different sorts of things. The fact that the prefrontal system and the limbic system can learn different things was revealed by the groundbreaking work of Dr. Brenda Milner, who essentially created the field of cognitive neuroscience, or the neurobiology of how we think. Based originally on Dr. Milner's insights, we now know that there are two neurobiologically distinct learning systems, one called explicit learning and the other called implicit learning. Explicit learning is the type of learning and memory that we typically mean when we say learning and memory. It's about information, facts, events, the sorts of things that we can actively, consciously recall when we need to do so. We use our fancy new prefrontal system to learn explicitly, and we tend to be consciously aware of this process. If you are trying to learn the different terms I've mentioned, then you are using explicit learning in your prefrontal system right now. In contrast, implicit learning mostly just happens. Implicit learning isn't expressed through conscious recall. Instead, what we learn implicitly shows itself through our habits, our sense of familiarity, our preferences and inclinations, our perceptual and motor skills, and some of our emotional reactions. To use an example from my experience in elementary school so many decades ago, explicit learning includes the facts and figures that I learned from watching educational films about science. At the same time, the films I saw in school typically only showed scientists who were white men with short hair. So the young me implicitly learned that only men are scientists. And I learned this without noticing I had learned it, which is why it's called implicit learning. Implicit learning occurs without any explicit recognition or conscious thought, nestled deeply in the shadowy, primitive limbic brain. If you're interested in hearing more examples, some very powerful examples, you should check out a TED Talk called The Danger of a Single Story by Chimamanda Ngozi Adichie. She speaks from a storyteller's perspective, and her message really resonates with my neurobiologist's perspective. So we have two systems important to making decisions, and each one is learning different things. On the one hand, we've got our complex, thoughtful prefrontal system, which uses what we learn explicitly and has the ability to think about the remote consequences of our actions. The prefrontal system prioritizes evidence, logic, and reason, and it really does set us apart from other mammals. You wouldn't be in college without the capabilities of the prefrontal system. In fact, colleges wouldn't exist as we know them. On the other hand, we've got the shadowy limbic system operating in our subconscious and using stuff we didn't necessarily choose to learn, but still learned implicitly. Implicit learning and the limbic system were really important in enabling our ancestors to respond quickly without wasting time on thinking, to avoid a predator and survive another day. The limbic system also strongly encourages us to be part of a social group, to fit in, something that had survival benefits as well. Imagine a scenario in which you need to make a decision that weighs the short-term effects against the long-term effects of that decision. For example, maybe it's deciding whether or not to get a newly created vaccine. There will likely be short-term flu-like side effects and long-term protection from a deadly virus. If you let your limbic system decide, what would you do? Get the vaccine or not? And if you let your prefrontal system decide, would you get the vaccine? Of course, neither system typically gets to make the decision on its own. And when these two systems are not in agreement, it sets up a bit of a battle. Your decision is a result of that battle between your prefrontal system and your limbic system. And by the way, when you are overtired or alcohol impaired, your prefrontal system is at a serious disadvantage in any battle with the limbic system. The limbic system also knows how to cheat, and we'll consider that in the second part of this talk.